can inform me. So up to here we have discussed. I think the screen is visible.
Yes, sir.
Yes, sir.
Yes,
Thank you.
sir.
We have discussed up to here. Now we are going to discuss something different in this reaction. As we have said, if you are having alkoxide as a catalyst or reagent, and the raw material is alpha haloketone, then we will get ester. If you are having OH minus, that is called hydroxyl group or hydroxide ion cation nucleophile, then we will get acid. If you are having amine, that is called NH2 or NH2 minus is there, then we will get amide. So three types of products we will get from alpha haloketone: acid, ester, and amide. Now today we are going to discuss about something different. By using the same reaction, Favorsky rearrangement, we are going to synthesize alpha beta unsaturated esters. So for that, the raw material is alpha alpha diketone or alpha alpha dash diketone. If you are having alpha alpha diketone or alpha alpha dash diketone, even though we will get the same product, means raw materials are different, but the product is same. So this is possible by Favorsky reaction. This in this rearrangement, what is important? Alpha dash hydrogen or alpha H hydrogen should be present. Means next to the carbonyl group on the carbon, one hydrogen should be present next to the carbonyl group. Okay, if carbon is there, that on that carbon one hydrogen should be present. If such type of case is there, then we will get the product or we can carry out the Favorsky rearrangement. Here we are having first example. In this alpha alpha dihaloketone, means on the same carbon we are having 2 Br. This alpha haloketone having alpha dash hydrogen, means here you can see one hydrogen is present on the carbon. If this is the case, in this compound or on this compound, RO minus will attack. When RO minus will attack, it will attack on hydrogen, and as a result, as we have discussed last time, in the first step, generation of carbon ion will take place. Here you can see generation of carbon ion will take place. Here negative charge on the carbon will form. Now negative charge on the carbon means this carbon is act as a nucleophile. Next to this carbonyl group is there, and carbonyl group is attached with the carbon, that carbon having halogen. As we know, halogen having tendency to pull electron from the carbon. When it pull electron from the carbon, it will convert it into C plus, means carbocation. When it converted into C plus, at the same time, this carbon ion will attack on this position. And as a result, what we will get? We will get cyclic structure. Cyclic propanone derivative we will get. Now in the cyclic structure, here the case is, here another halogen is also present. When the another halogen is present, that halogen having tendency to pull electron. Okay, when it having tendency to pull electron, this carbon become positive. When this carbon become positive, this carbon will pull electron from this bond. Why it this bond? Because here OR minus is there, that OR minus will attack on carbon of the carbonyl group. First OR minus will attack on this position. Then after the valency become, this carbon become 5, which is not acceptable. So immediately the breaking of this bond. When the breaking of this bond will take place, this bond means this bond when break, both electron will migrate on this position. So as a result, double bond will form. Already I mentioned why it happened. It is happened because of the characteristic of this group, living group. It is Br minus. Br will pull electron, and that's why this happened. And as a result, we will get carbon-carbon double bond, and here the ester. So in the previous structures we have discussed, alpha haloketone in the presence of alkoxide will give acid. But alpha alpha dihaloketone is present, then ester is formed. But at the same time, alpha beta unsaturated ester is formed. Alpha beta unsaturated ester is formed. So this is the change in this reaction. Now, next part we have discussed, that is called alpha alpha dash. Here it is alpha alpha, means on the same carbon. Here it is alpha alpha dash. Here this is alpha and this one is alpha dash. Here also halogen groups are there. But as per the characteristic of our reagent, that is catalyst, that is called RO minus alkoxide. Alkoxide first attack on the proton. When it attack on hydrogen, hydrogen will be eliminated as a proton, and that's why this electron will migrate on the carbon. When it migrate or transfer or shift on carbon, here you can see carbon having the which charge? Carbon having negative charge. When carbon having negative charge, it acts as a nucleophile, and this nucleophile will attack on alpha position. When it attack on alpha position, so same structures we will get, that is called cyclopropanone derivative. In the cyclopropanone derivative, as we have discussed earlier in this reaction, removal of attack of RO minus will take place and breaking of this bond will take place, and as a result we will get alpha beta unsaturated ester. This is called Favorsky rearrangement. So previously we have discussed about alpha haloketone open chain compound. In alpha haloketone open chain compound, the migration of the group take place. Then we have discussed about the cyclic structure. Here we have discussed about the cyclic structure. In the cyclic structure, what happens? Ring contraction will take place. Means if you are having 6-member ring, then we will get 5-member ring containing ester. Again, if you are having 6-member ring containing alpha haloketone compound, then by Favorsky reaction we will get 5-member ring containing ester. And here we have discussed that if you are having alpha alpha or alpha alpha dash dihaloketone, but by Favorsky reaction we will get the same product, that is called alpha beta ester. Now the main condition is the alpha carbon should have hydrogen, or alpha hydrogen should be present, or acidic proton should be present. So there are instance sorry sorry some compounds are there where alpha hydrogen is absent. If alpha hydrogen is absent, even though the reaction will take place. So this reaction is given by Cauchy, and it after first step it followed the pathway of Favorsky. That's why it is known as Cauchy-Favorsky rearrangement. Now in Cauchy-Favorsky rearrangement, as I said, alpha hydrogen should be present, but here in this compound alpha hydrogen is absent. Here also the alpha hydrogen is not present, even though this reaction is take place, but it is selective for specific type of compounds only. Here the reagent is, or catalyst is, hydroxyl ion OH minus. OH minus will attack on this carbon, and as a result it will converted into O minus, and OH will attach over here. After that, as we have discussed about the rearrangement, O minus will convert it into C double bond O. When it converted into C double bond O, here when double bond will form, at the same time the valency of this carbon become 5. So immediately the group will migrate from this position, means from here to here, and at the same time group will be eliminated. So leaving of group and migration both take place simultaneously in this reaction. That's why we will get C double bond O, OH and phenyl group over here. So here again repeating, O become O minus become C double bond O. Valency of this carbon become 5. When it become 5, immediately the migration of group will take place from this position to another position. Which position? Where the deficiency will form. How the deficiency will form? Because this Cl will be eliminated as a Cl minus, and that's why this carbon become electron deficient. This carbon become electron deficient, and due to this reason the group will attach on this position. So it is known as Cauchy-Favorsky rearrangement. કોઈ તમને પૂછે કે ફેવરસ્કી અને કોસી-ફેવરસ્કીમાં ડિફરન્સ શું છે, તો ફેવરસ્કી રિએક્શનની અંદર આલ્ફા અથવા આલ્ફા ડેશ હાઇડ્રોજન હોવો જોઈએ. કોની બાજુમાં? કીટોનની બાજુમાં. અને કોસી-ફેવરસ્કીમાં એ ના હોય તો પણ રિએક્શન થઈ શકે સ્પેશિયલ કન્ડિશનમાં સિલેક્ટેડ કમ્પાઉન્ડ્સ માટે. So this is known as Cauchy-Favorsky rearrangement. The reaction in detail for other important product, demerol, it's a pharma product. To synthesize the demerol, the reaction or whole reaction is based on Favorsky only. Means with the support of Favorsky reaction, we can prepare important pharma product. How? This instead of the normal cyclic compound, here heterocyclic derivative is there, but the pathways are the same. Means attack of OH minus on the carbon of the carbonyl group, it will convert it into COH and O minus. Then after this O minus will convert it into C double bond O, and at the same time this valency of this carbon become 5. That's why this group will be eliminated, but it will be eliminated or migrating from this position to this position because here the halogen is attached, halogen having tendency to pull electron, and that's why group will migrate from here to here, and as a result we will get this product. After that, by treatment with HCl and ethanol, we can convert it into hydrochloride salt, and this can be act as a pharma product API. Next feature of the Favorsky reaction is we can call it a semi-benzylic mechanism operator. Previously in the syllabus, benzylic acid as a rearrangement, but it was removed. Now, if you are having four-member cyclic structure in this compound, if you are treating this compound with OH minus, then reaction will take place on this position. Reaction will take place on this position rather than the reaction on here. આ પોઝિશન પર રિએક્શન નથી થતું, પણ આ પોઝિશન પર થશે if OH minus is there. If OR is there, then different thing. But if OH minus is there, then it will follow the pathway of semi-benzylic acid. It will attack on this position, and due to the attachment, OH is attached with now carbon and the oxygen which having negative charge. But this oxygen will again converted into C double bond O. When it converted into C double bond O, new bond will form over here, and as a result, valency of this carbon become 5. So this group will migrate with electron. When it migrate with electron on the neighboring carbon, means this position. Why on this position? Because it is attached with the halogen, and as a result the ring contraction will take place, and we will get cyclopropanoic acid. We will get this one is the simple compound or smallest heterocyclic compound we can synthesize by this reaction, that is called use of Favorsky reaction. But it is not exactly like benzylic acid, benzylic acid rearrangement. It is not exactly like Favorsky reaction, but some steps of benzylic acid and some step of Favorsky it follows. That's why its name is semi-benzylic mechanism operate via Favorsky reaction. Now if you are having 7-member ring, then we will get 6-member ring containing ester or acid. This part is already I have discussed, or mechanism I have already discussed for the 6-member ring. For the same pathway or same reaction will take place over here. Here, as we know, here carbon is attached with what? Hydrogen. Two hydrogens are present. Now RO minus will attack on this position, and as a result, what happened first? Here OR will attack on this position. When it attack on this position, means on hydrogen, hydrogen will be eliminated as a H plus. When hydrogen is eliminated as a H plus, so what we will get? Negative charge on this position. And as we know, negative charge on this position, this carbon will attack on this uh, carbon where halogen is attached, because halogen having tendency to pull electron, and it will be eliminated as a Cl minus. So this carbon become positive. When this carbon is positive, the attachment of the group or a bond formation will take place, and finally or ultimately we can say here cyclopropanone derivative is formed. When we are having cyclopropanone derivative, OR minus will attack on this position. Okay, when it attack on this position, oxygen will pull electron, and the bond formation between COR will take place. Again, O minus will attack on or converted into cyclo sorry converted into carbonyl group, that is called C double bond O group, and that's why the breaking of bond take place, and finally we will get a 6-membered ring containing ester. 6-membered ring containing ester, or we can say our cyclohexane having ester group. So this is formed by, or this is possible by, Favorsky rearrangement. If you have any question, query regarding the same, you can raise your hand. I will answer your queries, and if not, then we will move further.
So can you repeat this last slide?
Last slide is the same, means whatever we have discussed for 6-member, same principle will be applied. Here you have to consider this part as a R1 R2, this part as a R1 R2 only. Okay, so the ring may be 6-member or 7-member, but the mechanism or pathway of the mechanism is same. Pathway of the mechanism is the same, means what? First of all, OR minus will attack on the hydrogen, the carbon become negative, that is called carbanion will form, and after that this carbanion will attack on the carbon where the halogen is attached. Why it is on this position? Because halogen having tendency to pull electron, that's why we will get positive charge, and as a result we will get cyclic propanone type of derivative. When we are having cyclic propanone type derivative, OR minus from alcohol, that is called ROH, will attack on this position. So it will convert it into O minus first. Then after, O minus will convert it into C double bond O, and as a result the breaking of bond will take place, and we will get ester. But ring contraction will take place. Means from 7-member ring we will get 6-member ring containing compound. ઓકે, બીજા કોઈને ક્વેરી છે?
સર
હા,
તમે આરો માઇનસ નું જે એક્ઝામ્પલ આપ્યું, જેમાં આરો માઇનસ જ્યારે આપણે યુઝ કરીએ છીએ ત્યારે એ આલ્ફા હાઇડ્રોજન પર અટેક કરે છે, તો જ્યારે આપણે OH માઇનસ નો યુઝ કરીએ તો એ કેમ આલ્ફા પોઝિશન પર અટેક નહીં કરે અને કાર્બન પર કરશે?
એ સિલેક્ટેડ કમ્પાઉન્ડ માટે છે, જે રીતે આની અંદર છે, આની અંદર એ અહીંયા એટેક કરે છે, બરાબર? અહીંયા એટેક નથી કરતું. રિંગની જ્યારે સાઈઝ હોય છે તો રિંગને જેટલું સાઈઝ નાનો તેમ એની અંદર રિપલ્ઝન મેક્સિમમ હોય છે. સચ ટાઈપ ઓફ રિંગ્સ આર નોટ સ્ટેબલ. એટલે આ જે હાઇડ્રોજન છે એ એક્ટિવ હોવા કરતા અહીંયા રિપલ્ઝનને કારણે ઓક્સિજન પુલ કરી લે છે ઇલેક્ટ્રોન, અને ઓક્સિજન જ્યારે ઇલેક્ટ્રોન પુલ કરી લે છે ત્યારે આ જે પોઝિશન છે એ હાઈલી ઇલેક્ટ્રોન ડેફિશિયન્ટ થઈ જાય. કેમ કે તમે ઇલેક્ટ્રોનનું રિપલ્ઝન જો સ્ટડી કર્યો હોય અથવા ભણ્યા હોય તો સૌથી વધારે રિપલ્ઝન જે થાય છે એ નોન બોન્ડ પેર, નોન બોન્ડ પેર, પછી આવશે નોન બોન્ડ પેર અને બોન્ડ પેર ઇલેક્ટ્રોન, ત્યાર પછી બોન્ડ પેર અને બોન્ડ પેર રિપલ્ઝન. તો અહીંયા આગળ શું છે કે રિંગની સાઈઝ નાની છે એટલે અહીંયા આગળ મેક્સિમમ રિંગ સ્ટ્રેન આવે અને એના કારણે આ જે ઇલેક્ટ્રોન છે એ અહીંયા રહેવાને બદલે એ ઓક્સિજન પાસે વધારે રહે. મતલબ અહીંયા જે ઓક્સિજન છે નેગેટિવલી ચાર્જ બિહેવ કરે, એ નેગેટિવલી ચાર્જ બિહેવ કરે તો કાર્બન પોઝિટિવલી ચાર્જ બિહેવ કરે. એટલા માટે એ મોર એફેક્ટિવલી HO જે છે, OH માઇનસ જે છે, મોર ઇફેક્ટિવલી અહીંયા વર્ક કરશે. એક રીઝન છે. બીજા જેટલા પણ આપણે એક્ઝામ્પલ્સ જોયા છે આગળના, એ બધાની અંદર શું છે, ઓપન રિંગ છે અથવા 6 મેમ્બર રિંગ છે અથવા 7 મેમ્બર રિંગ છે. તો 6 મેમ્બર અને 7 મેમ્બર રિંગ્સ જે છે એ વધારે સ્ટેબલ છે એઝ કમ્પેર ટુ 3 અને 4 મેમ્બર રિંગ. આ એક મેઇન રીઝન છે એનો. ઓકે, બીજા કોઈની ક્વેરી? Okay, I'm moving for the next slide. Now we are going to discuss about another type of migration that is called C2N migration. અહીંયા ખાલી એક 1 મિનિટ એક ઇન્સ્ટ્રક્શન આપી દઉં છું. જેવું મારું લેક્ચર પૂરું થાય કે ઇમિડિયેટલી અર્ચના મેડમનું લેક્ચર જે છે એ જોઈન કરવાનું છે. પ્રણવ સરના લેક્ચરને બદલે અર્ચના મેડમનું લેક્ચર જોઈન કરવાનું છે. જેવું 3 and 5 or 10 મિનિટ્સ થશે એટલે હું લેફ્ટ કરીશ અને ઇમિડિયેટલી તમારે નેક્સ્ટ મીટિંગ જોઈન કરી લેવાની છે. જે રીતે હમણાં 20 મિનિટ કે 10 મિનિટ લોકો લેટ આવ્યા એવું કરવાનું નથી. Again, I am requesting you all, after this connection or after leaving the meeting, my meeting, you have to immediately join the next meeting of Archana Madam. She has already planned lecture for you, but I don't have proper information. That's why I have arranged my lecture in between. Okay, now I am going to discuss the C2N migration. In the C2N migration, first of all, when we can consider nitrogen is electron deficient. Already we have discussed when nitrogen become electron deficient. So can you explain, or anyone can say in which condition we can consider nitrogen is electron deficient? તમારમાંથી કોઈ આન્સર આપી શકે આનો?
If lone pair of electron of nitrogen is donated to other, then nitrogen is electron deficient.
Okay, fine. Or any other case? He has rightly said, if nitrogen has donated its electron, then we can say nitrogen is electron deficient. Here I am going to explain you or brief you what is the difference between this and the intermediate which I am going to discuss. Okay, here as he said, here if we are having R, another R group, and here also R, means nitrogen is already fulfill its valency. Nitrogen having 3 valency. But as he said, if nitrogen donate electron, means this electron to something else, suppose hydrogen, then nitrogen will gain positive charge. Now nitrogen having positive charge, it means we can say nitrogen is electron deficient. It means nitrogen should react with nucleophile. Now tell me, is it true that nitrogen, if nitrogen having positive charge, then nitrogen can react with OH minus nucleophile? Anyone can answer.
Can
If
you
nitrogen having positive charge, and this is the form which I have written over here. Bolo.
Sir, it will not be electrophile.
Why? Why we cannot consider as an electrophile? Here nitrogen having positive charge only because of in the bond formation only nitrogen has shared electron. અહીંયા નાઇટ્રોજન જ ખાલી બોન્ડ ઇલેક્ટ્રોન આપ્યા છે એટલા માટે આપણે એને શું કહીએ છીએ પોઝિટિવલી ચાર્જ because the substance or element donating electron we should consider as a electron donor. When it donate electron it will gain positive charge. It is true, but as per the octet rule, this nitrogen having sufficient number of electron means 1 2 3 4 5 6 and 7 8. So this nitrogen is not an electron deficient as per the octet rule. Sufficient number of electrons are available on surrounding or of nitrogen. So we cannot consider as a electron deficient. Here the positive charge is there only because of the bond formation is take place, but in that bond formation only the electron from nitrogen is transferring to the hydrogen. Okay. Second, I have asked that if this is the condition, then nitrogen can react with nucleophile, means can react with Nu minus. Okay, Nu minus means nucleophile. This is it possible? No. Why it is not possible? The reason is nitrogen having 3 valency only, and in the maximum condition it can form only one coordinate covalent bond. But if we consider this nitrogen is electron deficient, then it should act with or form a bond with nucleophile. Normally we see for we can discuss or we have observed in carbocation. Carbon having positive charge, then definitely that carbon will react with the nucleophile. It is possible, but here it's not possible. Okay, so this type of formation or reactions will not possible. So here nitrogen, again repeating, nitrogen having positive charge only because of nitrogen has shared electron to the hydrogen. But we cannot consider as a electrophile, we cannot consider as a reactive species where nucleophile will attack, because as per the octet rule sufficient or it following the octet rule, it means sufficient number of electrons are available in the surrounding of the nitrogen. And nitrogen having sp3 hybridization only, remember always, it having sp3 hybridization means nitrogen can form only 4 bonds. Out of 4 bonds, 3 bonds are covalent bond and 1 bond is coordinate covalent. Now I am going to talk about electron deficient nitrogen. And already we have discussed, that's why I have said, okay, we have discussed, but I think you have not remembered what we have discussed. We have discussed about the characteristic of nitrogen, and in that characteristic of nitrogen, nitrogen having only one bond. And when nitrogen having one bond, here two electrons with nitrogen, that is called lone pair of electron of nitrogen. Okay, one electron by the formation of the reactive intermediate, another electron is also by formation of the reactive intermediate. Now I think based on the structure you are having the idea that I am talking about which reactive intermediate. Can you answer? I am talking about reactive intermediate. Looking to the structure,
Carbene. Carbene.
is this a carbon?
Carbene, sir.
Nitrine.
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 Nitrine. Nitrine.
Okay, I am talking about the nitrine. Now, why it is electron deficient? So based on these structures only you can say nitrogen having how many electron? 1, 2, 3, 4, 5 and 6. Means as per the octet rule, nitrogen having deficiency of 2 electron. Second thing, here no positive, no negative charge. Neutral atom is there, neutral group is there, neutral reactive intermediate is there. Even though based on the octet rule, we can say this is electron deficient species. And if it is electron deficient species, then we can carry out reaction by nucleophile, that is called, already we have discussed, Nu minus. If you are having Nu minus, that is called nucleophile, the nucleophile can bind or react with this and we will get the product. This is one possibility, or migration of the group will take place. Migration of the group will take place from means what? Migration of group from electron sufficient carbon to electron deficient nitrogen will take place. So now in this reaction or this rearrangement, we are going to discuss about this. In this rearrangement, we are going to discuss about Smith rearrangement. For Smith rearrangement, I have talked in a reactive intermediates, but at present or we are discussing or we are going to discuss in detail about the Smith rearrangement. If you are having acid and if you want to convert acid into amine, then you can carry out reaction by Smith rearrangement. We can convert acid into amine directly. Normally, if you want to convert acid into amine, then first of all you have to either convert it into ester or acid chloride. Then after you have to treat it with ammonia. You have to convert it into amide first. Then after you have to follow the pathway of the Hoffman reaction. In that reaction, first it will convert into isocyanate, and then after by treatment with water, it will convert into carbamic acid, and then after finally it will convert into amine. But if you follow the pathway of Smith reaction, then several steps, I am not saying this reaction will be possible in one step, but several steps can be minimized or removed or eliminated. And in the minimum step of the reaction, we can convert acid into amine. So this is the reaction where the Smith reaction or Smith rearrangement we will follow. How the reagent it will form. I'm just giving you the brief idea, and later on we will discuss about the reaction. Okay, right now instead of discussing all these things, I'm going to conclude the session at present because of the other lecture is going to start. So I am requesting you At present, just leave the meeting and join Archana ma'am's lecture. But tomorrow I have arranged lecture at 4 to 5. In that lecture, we will discuss all points in detail. Okay. So I am requesting you all, please leave the meeting and you are requested to join the another meeting. But tomorrow we will discuss in detail about the nitrine and further rearrangements. Thank you.